Welcome to Physics of Life Biomechanics. I'm glad you're here. Biomechanics is the subject of the second module in a series of 4 that make up the course in Physics of Life. The other modules are concerned with thermodynamics, fluids, and wave phenomena, such as light and sound. Thermodynamics was the first module. Biomechanics is the science of how force and energy applies to living things. It's just like mechanics, but applied to life. We're going to take 2 basic approaches to this subject. First, there's the science of materials, that is, how materials bear and distribute loads. Just as buildings are constructed from materials such as steel, glass, and concrete, living things are made up of materials such as bone, connective tissue, wood, and many more. The very same problem of being able to bear and distribute loads without failing applies to living things as much as it does to things that we ourselves build. We don't want our buildings falling down, and we don't want ourselves breaking and falling down either. The difference is that living things meet these goals by making a number of clever materials with novel properties. We're going to explore some of these novel properties and explore just what it is that makes them novel. We're going to explore basic concepts of stress and strain, and material properties such as elasticity, toughness, and strength, which help illustrate just how clever these materials are. Our second approach explores the biomechanics of locomotion, that is, the problem of getting living things moving through space. To move a body forward, force generated by muscles must be applied to the outside world. A foot can only push against the ground if there's a muscle generating the force. We're going to explore how this transmission of force works and some of the design principles that make for efficient use of muscle energy. We're going to explore how skeletons act as lever systems and the important role that storage of muscle energy in elastic tissue plays, including the physics of jumping. Speaking of skeletons, we're also going to explore just what skeletons are. We tend to think of a skeleton as articulated, rigid elements such as bones and joints. Surprisingly, skeletons can also be made from water, so-called hydrostatic skeletons. These are the province of soft-bodied animals like worms, mollusks, and other invertebrates, but also things like tongues of chameleons and trunks of elephants. Hydrostatic skeletons comprise some of the most versatile skeletal systems in the animal kingdom, far more versatile, in fact, than our own skeletons made from bones, and we're going to see why. Finally, we're going to explore the physics of different types of locomotory gaits, including walking, trotting or jogging, and running or galloping. So, without further ado, let's jump in, so to speak.